So the question on the screen says an elliptical loop having resistance R of semi-major axis A and semi-minor axis B is placed in a magnetic field as shown in the figure. We are provided with the two different figure. So first figure is just the coordinate axis, and the second figure is the real figure describing in the questions. So it is saying further that if the loop is rotated about the x-axis with the angular frequency omega, the average power loss in the loop to joule heating is, and then we are provided with the four different options. So now let's understand the solution for this question. Here it is given that phi, that is phase, is equals to BA cos omega t. We know that it's a simple thing we studied in class 11th in physics. So the phase is equals to BA cos omega t. So after that we know epsilon is equals to d phi by dt. We will put the value of phi and then we will differentiate with respect to 2. Then we will get the value of epsilon, and epsilon naught will always be equals to when b pi ab omega. Now after that, what we will do, we will find out the value of p, and p is equal to what? Epsilon square by r, which is we will put the value of epsilon and to the whole square. After that, uh, that value we have to take the average value, right? So for average value, what we will put, uh, the sine square theta is equals to 1 by 2. After putting this, we will get the value of p average, that is b square pi square a square b square omega square by 2r. So according to this, our answer that is true is option 3.